So this week we're going to talk about moisture and vertical motion and instability. So what we're really doing is starting to generate precipitation in the clouds or clouds themselves. So what I started off with here is a picture from satellite of mid-layer of moisture, which is right around 700 millibars, or about 10 to 15,000 feet up in that area. So the greener it is, the more saturated the air is. And you can see the moisture that's hitting the East Coast right now is literally coming out of the Pacific Ocean and moving up that way. You can also see there's moisture off of the California coast right now, and lots of dry air too coming out of the desert Southwest here. And there's some more moisture coming into the Pacific Northwest. So this is a great tool just to get a quick picture of where all the moisture is. But one of the things that's interesting is, while it's neat to see where the moisture is, where's the vertical motion going, or what's happening to generate precipitation out of these moisture. So this is a 300 millibar at some close to the same time as you were just looking at. Divergence is air spreading apart aloft, which is basically allowing you to pull air from below there to come up and take its place. So the air is rising. As the air rises, it cools. As it cools, it condenses the moisture out of it. It can't hold as much moisture. So the more divergence, the better the precipitation chances. And you can see several areas here over Georgia, South Carolina, western parts of North Carolina, and into West Virginia here, and also some further north. So these would be the areas you would expect some precipitation to be falling out of that area. Another place to look for moisture and maybe even see some other things going on is an 850 millibar chart. And you can see the southerly flow here ahead of the cold front that's coming in, pulling moisture up out of the Gulf of Mexico at the low levels. So that's saturating the air as well to provide even more moisture to that area that we're seeing where the precipitation is right now. And when you look at upper air soundings to go along with that, this is Albany, New York. You can see it's completely saturated all the way up, literally up above 200 millibars. So there's a dense cloud layer there. If you're flying in it, you're not going to be getting out of the clouds till you get pretty far up in the atmosphere, probably above 30,000 feet. One of the interesting things I noticed was the temperatures actually go above freezing, right above 850 millibars. So there's an area there, if you're flying as a pilot, you would actually hit temperatures that would allow the water droplets to melt for a little bit. Then if you go up or down, they're going to be freezing again. So there's some icing potential in this sounding here too. It's showing it. But this sounding is very stable. There's no instability in it. However, last night we had a tornado occur in Alabama, and this is Birmingham sounding last evening. It's not real unstable, but if you had temperatures of 68 degrees, you're going to move your air parcel up stability-wise over here along the moist adiabatic, since it's very moist, and you're always going to be warmer than the actual temperature of the sounding all the way up here. So that means there is some instability there since warmer air rises. So you're actually helping to generate a little bit of motion there. So that, with the divergence aloft, is helping to enhance this vertical motion. So that's why they had some potential for some tornadoes last evening down in that area. There was some weak low-level instability there to help them along. So here currently is our current weather map. And just looking at the surface map in detail here, you can see the dew points are in the 60s on one side of this front, and they fall off into the teens on the other side of it. So there's a sharp contrast at low levels. If you were flying across this front, you would be going from very moist, very humid air to very dry, very dense air very quickly. So it's another thing to consider as part of when you're flying, what hazards you might be facing, how your altimeter might be changed as you fly across this boundary. keeping in mind what we've learned so far. So there's lots of hazards going on today, as we just talked about, the moisture we're looking at here. So if you have any questions about this, please just don't hesitate to ask.